So now we learn on future lifetime. The notation for future lifetime is Tx. The symbol X is used to denote a life age X. The future lifetime of X is the big X minus X. So the current age is small x and the time of death the age of death is big X. Age of death. So to know the future lifetime of X, we have to take age at death, the big X, minus the current age. This is age at death. When no confusion about the present age of the individual is likely, we simply denote the future lifetime variable by T. So we also can use this notation instead of the Tx. But it's referring the future lifetime of X. Okay. So first function is this SDF of T, or the survival distribution function for T. So if the survival distribution function, when we write down in terms of probability, the T must greater than T. So it is the conditional probability whereby the X must be greater than X, where an individual must survive until X. So survive here. So now we want to know the probability of survive from X to age at death. So this one referring to this probability, and this one referring to this conditional probability. So then we get the SDF of T is Sx for the time x plus t over Sx for at time t. So we get Sx plus t over Sx. So note that for the first one, S0, meaning that for a newborn child. So if we draw the timeline, 0 to x, or 0 plus x, 0 plus x plus t. So the period here become x plus 0 minus 0 equal to x, and here become minus, so we get t. So that's why S0 at x plus t is at 0x times Sx t. So this one is x 0 because the current age is 0, and this is the current age is x. That's why it becomes S0 SX. That's why it becomes SX T. Okay, the second one. If we draw the timeline, from X, the current age is X, so the current age is X, to X plus T, the second one, the current age for the second one. So the period here is X plus T minus X is become T, and at the end is X plus T plus A. So the period is A, X plus T plus A minus X plus T. So that's why we get SXT. So this is X plus T. So SX plus T. The time, the period is T. So A T. The second one is the PDF. So the PDF, how to find the PDF? We differentiate the survival function and the negative sign in front. And we get fx, x plus t over sx. So far, the SDF for future lifetime is sx plus t over sx. So the PDF second one is the PDF So now we go to example 2. If Sx at x is equal to 1 minus 0.01x for age 0 to 100, find first the median age at death m. So median age, median means at the center point or the midpoint. So you are given the age in range of 0 to 100. So we denote the age at death as omega. So the omega equal to 100 years. So the midpoint must be equal to 50. 100 divided by 2. We get 50. So m is equal to 50. So B, find the SDF and the PDF of future lifetime of m. So m is 50. So B, the SDF for future lifetime at m equal to 50. So Sx 50 is equal to, we plug in the function and we get 0.01. So the SDF is future lifetime so we substitute X with 50 and we will get 50 plus T over 1 minus, or we can straight away put 0.5. So then we get 1 minus 0.02 T. So when we get the Fx, when we get the Sx, we also can find the CDF or the DF. So the big F by so when we get the SDF, we also can get the CDF. So by minus 1 minus SDF. So 1 minus 0.02 T. So the CDF is equal to 0.02 T. And then we can find the PDF. So the PDF is FT we differentiate the CDF, we will get the PDF. So expected value is the ET. So the bound must be 0 to T. So T is equal to 50 for this case. So T times the PDF. Then we integrate and we get T squared over 2 from 0 to 50 and we get 25 years. So this is the expected future lifetime. If we want to convert it in terms of age, so at what time he will die? This is period, future of lifetime. So he will die at age 75 years. 50 plus the future lifetime 25 years, so 75 years. Now we go to example 3. So A so this is sign for probability of death. How we can determine that? Because the probability is less than T or less than because it is less than t. So it's referring to probability of death. So big F is CDF. Since we are given in terms of survival function, so we change it into survival function term. And we get T is 45. We plug in. So we plug in into the equation. It becomes 0.445. So first you have to check the sign here. So this sign is referring to the probability of death. B. Probability T0 greater than 80. So B, probability T0 greater than 80. So the sign is greater than. So it's referring to the survival function. So as 0 at t equal to 80 is equal to, so we plug in the 80 into the function straight away because we are given in terms of survival function, and we get 0.2. And we get 0.2. T0 from 45 to 80. So we can use this equation. The probability of death before 80 minus probability of death from before age 45. So this one we can use 1 minus probability T0 greater than 80 minus so we can use the value from previous equation. So 1 minus 0.2 minus 0.45. So we get 0.35. So next section is about actuarial notations. To make probability statement about Tx, so the future lifetime of X, the first notation is TQX, referring to probability of death for an individual at age X. If we draw the timeline, X and X plus T. So the future lifetime for X is T. So T here is the future lifetime for X. So we write down in front of the Q, and the current age, the X, is here. Second one, TPX. TPX is probability of survive of an individual at age X. So if we draw the timeline, X is the current age. So here is the current age. And future lifetime TX plus T. So here it becomes T years. So T years is referring to here. So if we write down the probability of death in terms of probability, is this less than T, and for survive the probability must greater than T. So before this we use notation of, this one is CDF. This is the statistic notation, and then this one is SX. In the survival model, in the statistic, we use this notation. But actuarial also have their own notation. So in actuarial notation, we use TQX for probability of death and TPX for probability of survive. So TQX as the conditional probability of death in the age interval X to X plus T, given that alive at age X. Why we call it as conditional probability? Because we have to assume that from 0 to X, meaning that the newborn must survive. So alive at age X. So the interval here referring to this interval. TQX can be interpreted as probability that a person age X will die within T years. So if we want to use in terms of the SDF and the FX, we write down like this. Second note.